All right, the next best practice, and I actually combined two. There was two here that Dan mentioned. For the purposes of Tabular, I'm going to talk about these two things together because in Tabular's world, we think about these two functions in Unity. So maintaining tables and optimizing performance. And the best practice for maintaining tables was, hey, aggressively maintain your tables, right? At Tabular, we take a slightly different stance on this, which is intelligently optimize your tables, right? So aggressively maintain in a lot of cases for people using open source is, well, I'm going to set up a cron job every hour to go and compact all my tables. Or at the end of every ETL job, I'm going to run a compaction or a metadata rewrite or whatever it is that I need to perform maintenance on my Iceberg tables. And that's okay, but it turns out we can actually do a lot better than that if we bring some intelligence into our maintenance services. And so in Tabular's land, we connect the catalog activity with our maintenance services so that on every commit to a table, every change to a table, we are inspecting that set of changes. We are looking at historical performance of a table, and we're deciding when is a good time to run maintenance activities. So A, that they stay out of the way, and B, that we're maximizing the value of actually doing that maintenance. Are we going to be able to compact a lot of small files? Are there more files likely to come into this partition in the next 5 minutes? Maybe we should wait, things of that nature. The other best practice around optimization was enhancing your data engineering practices with Iceberg features. So those are things like using hidden partitioning, et cetera. At Tabular, we would say, hey, the Tabular platform has got all that baked in. We already leverage all the Iceberg features to optimize the physical layout of your tables. And that just allows your data engineering team and the rest of your data users to focus on business value. These are very low level things that honestly platforms really should be doing. And we don't need data engineers to spend a lot of time thinking about, are they optimizing the right partitioning scheme? Are they sorting on the right things? Are they clustering on the right keys? Again, we can leverage the catalog to look at read and write patterns for tables and automatically choose the best physical layout for your Iceberg table that's going to minimize the cost as well as maximize the query performance. I'll talk more about that coming up. Okay, well, so when we talk about intelligent maintenance, intelligent optimization, what are some of the key things? So snapshot expiration, this is the act of removing old history from your Iceberg tables. We do that automatically at Tabular. You don't even really think about it. There's take the defaults are mostly good. You also have configuration about if you want to keep longer history or shorter history. We can do that automatically for you. Orphan file cleanup. This is hey, sometimes you have jobs that run that maybe don't actually commit data. They've written data to disk, but don't ever commit it to the table. So you have these orphan files that are left around. We handle cleaning all those up in a very optimal way. And things like rewriting metadata. So, if you're, again, streaming a lot of data into a table, you're going to build up a lot of metadata over time. And oftentimes that metadata isn't aligned with your query patterns. And so we want to take your Iceberg metadata, rewrite it in such a way that it aligns with your query patterns so that when engines are running queries against your table, we're getting the maximum value out of Iceberg's indexing and file pruning capabilities. And again, we're looking at those query patterns against your tables so that we can make sure to line that metadata up with your query patterns. All this is fully automated. It's kind of set and forget stuff. You don't worry about it if you're using Tabular's platform. In addition, all those data engineering activities, these are things that even at Netflix, we had a lot of data engineers who spent a lot of time focused on trying to solve these problems. And I'm really happy to say that the Tabular platform handles all this stuff automatically, and it does it in a very intelligent way. So obviously compacting small files, we're all very familiar with the small files problem and why we have to compact those things in large tables. Again, we do that very intelligently, deciding when to compact files, how many files to compact at a time. If you've tried to do this yourself in other engines, there are a lot of challenges with doing it at scale. You got tens or hundreds of thousands of jobs. You have to contend with memory challenges and commit contention. And we're handling all that behind the scenes in Tabular. Taking advantage of partitioning, sorting, all that stuff is handled by Tabular's optimizer. Again, we are able to see the scans that happen against your Iceberg tables when queries are being run. We know which predicates are being used across different queries, and we can really auto cluster and line up the physical layout of your Iceberg table to maximize the performance of those queries, as well as reduce the size of your data on disk. Even choosing the right compression codecs, which I don't mention here, is something that we do automatically. So, should it be Z standard? Um, should it be gzip? Should it be snappy? And the reality is, it depends. Every data set is different. Every data set responds differently to different compression codecs. And our system is smart enough to choose the best one on a table by table basis.